Welcome to AI Paper Podcasts. We're the place where we cut through all that dense research noise and pull out those key insights you really need to stay right on the cutting edge. Today, we're jumping into a really fascinating paper, one that looks like it could be a pretty significant leap forward for robotic AI.
Yeah, absolutely. We're looking at some groundbreaking work here from Jun Sen and colleagues. They're at Demo Academy, Alibaba Group, Hupan Lab, and also Zhejiang University. The paper's called World VLA, Towards Autoregressive Action World Model, and it just came out June 27, 2025. And it really goes after a core problem in robotics, like a really persistent one. How do you get these intelligent agents to not just, move around, but to truly understand and interact with the complex physical world?
Okay, so for everyone listening who wants the quick version first, maybe you're walking the dog or commuting here, are the key takeaways on World VLA. This is the gist you'll need.
Right. So first off, World VLA introduces this new AI model, and what it does is it unifies two really critical functions that used to be separate. That's one, understanding and generating actions, and two, predicting what the world will look like next, visually.
Okay, so action and prediction together.
Exactly.
Yeah.
Because historically you had action models great at making the robot do things, but not so great at understanding the environment deeply. And then you had world models, fantastic at predicting the future visually, but they couldn't actually generate the action.
Oh, I see.
World VLA smashes those together. So now understanding the action helps predict the visuals better, and predicting the visuals actually helps generate better actions. It's a loop.
Cool. What's the second point?
The second big thing is this innovation they call an attention masking strategy. Now, this tackles a really common and frankly annoying problem with what's called autoregressive action generation.
Autoregressive,
Yeah.
meaning it builds actions step by step based on previous steps.
Precisely, like writing a sentence word by word. The problem is, if you make a mistake early on, that error just gets bigger and bigger down the line, right? So for long sequences of robot actions, this could lead to complete failure. Their new strategy stops that error buildup. It's a clever trick that really boosts success rates in complex tasks.
Okay, that sounds crucial. And the third insight.
And third, the bottom line is World VLA just performs better, consistently better than the older standalone models. We're talking about making robots significantly more capable, especially in tasks that need really precise movements and a good grasp of, physics, how things work. It's a step towards robots that actually genuinely get the world they're in.
Okay, that's a great summary. Let's unpack that a bit more now. We've seen, huge progress in AI, especially with these vision language action models, the VLAs. They see, understand language, and act. So what was the core limitation? What were they missing that made something like World VLA necessary?
That's the perfect place to start. So current VLA models, they are fantastic at perception, at making decisions. Often they build on these big pre-trained models, MLLMs. And yes, they generate actions, but here's the key thing. They mostly treat actions just as outputs.
Outputs only.
Right. They don't really feed the information about the action back in as an input for deeper understanding. So think of it like a robot can make a grasping motion maybe, but it doesn't fully get the physics of that grasp or how it changes the world state in a fundamental way. It's kind of superficial.
Like someone reciting a phrase without knowing what it means.
Sort of, yeah. Good analogy. They lack that deeper integration of the action itself into their world understanding.
Okay, so if VLAs are good on output, but maybe weak on understanding the input implications of actions.
Yeah.
What about world models? You said they predict future states.
Exactly. World models are really good at that. They look at what's happening now, consider an action, and predict what the next camera frame will look like. So they get a pretty good handle on visual information and the dynamics of behavior, cause and effect, visually.
But they can't act.
That's their limitation. They can't directly generate the actions. They can predict the outcome if an action is taken, but they can't decide which action to take. So there's this gap, right? It limits how you can use them directly for tasks that need the robot to actively plan and execute steps. They're observers, not actors.
Got it. So, okay, if I'm following this, it sounds like we have these two powerful toolkits, but both were incomplete. One's a doer that doesn't fully get the consequences. The other's a thinker that can't actually do. So the big idea, the mission of World VLA is really to fuse those two together, to bridge that gap.
Precisely. That's the core objective. World VLA aims to tackle these limits head-on by creating this autoregressive action world model. One system. A single integrated model that can both predict actions, acting like a policy, and forecast future states, acting like a world model. It's about merging the doer and the seer into one coherent AI.
That sounds ambitious. How does it actually work? How do they achieve that unification? Could you give us a glimpse at the architecture?
Absolutely. Let's peek under the hood. So the overall architecture, they show it in figure 2 in the paper. It actually starts from another powerful unified model called Chameleon. But the really fascinating bit is how World VLA uses 3 separate tokenizers. One for images, one for text instructions, and one for the robot's actions.
Okay, 3 different inputs.
Right, but here's the kicker. The tokens, the sort of digital words that come out of all 3 tokenizers, they all share the exact same vocabulary.
The same dictionary for pictures, words, and movements.
Exactly. It's this unification within a single large language model architecture that lets it understand and generate across these different modalities. It's like teaching the AI a universal language where words can represent pixels or text characters or even, the angle of a robot's joint.
Wow, okay, that is clever. So treating actions and images just like text tokens lets the big language model process everything together. Can you quickly describe what these tokenizers are doing?
Sure. So for images, they use a type of model called a VQGN. It's good at turning high-res images into these discrete tokens, like breaking a picture into visual words. For actions, robot movements are usually continuous values, like positions and angles. The action tokenizer discretizes these, turning them into a sequence of distinct action tokens, maybe 7 tokens per action step. And then the text tokenizer is more standard, like you see in LLMs, but crucially, its vocabulary includes all the image tokens and all the action tokens too. And then all of this data, images, text, actions, all represented as these shared tokens, is trained autoregressively. The model learns to predict the next token in a sequence, whatever it represents.
That makes sense. That deep integration is key. Now, how does the way they train this model reinforce that idea of mutual enhancement? You said the action model and world model parts make each other better.
They do, yeah. The training strategy is quite smart about this. They basically mix data that's typically used for training action models with data used for training world models. And there are really 3 key reasons why adding that world model data helps the action generation part.
Okay, where are they?
First, the world model part learns the physics of the environment, right? By predicting future images based on current states and actions, that understanding of cause and effect is super important for manipulation.
Right, like knowing if you push something, it'll move.
Exactly. Second, this prediction ability lets the system kind of simulate internally. It can evaluate, okay, if I try this action, what's likely to happen? And it can avoid actions that lead to bad outcomes before actually doing them.
Like running a quick mental check.
Pretty much. And third, to make good predictions, the world model needs a very precise understanding of what the action input actually means. This forces a better interpretation of actions, which then helps the action model generate more effective, physically grounded movements.
That's a really neat feedback loop. So the world model helps the action model predict consequences and be more precise. What about the other way around? How does having the action model help the world model predict better?
It works both ways. The action model, because it has to figure out the right action based on the image input, it develops a more accurate interpretation of the visual scene and the patterns of behavior happening. This deeper understanding then feeds back into the world model. It means the world model isn't just predicting any plausible visual change, it's predicting changes that are specifically linked to and likely caused by the actions being considered or taken.
So the predictions become more relevant, more grounded in actual interaction.
Exactly. It leads to more physically coherent and useful predictions. This whole bidirectional thing makes the entire model much more robust and comprehensive.
Okay, so the paper also flags this significant challenge with autoregressive models, right?
Yeah.
This performance drop when you generate longer sequences of actions. These action